Hi friends, welcome back. So we are here with another video. So in this video we will do analysis to identify the letters of the English alphabets, right? So this is the data information that we have. We are taking our train and test set from this Avila Bible data set, right? And we will use this with our data, right? So data have been normalized by using the G normalization method and divided into two data set. Okay, a training set containing 10,430 samples and a test set containing the 10,437 samples. So these are the attribute in our data like f1 f2m. So these are intercolumnar distance, lower margin, so on so forth. And there is one attribute, that is class, which have abcd or the alphabets like that. Now again, this is the problem statement to identify the letter of the English alphabet from the this particular sample containing these characters, right? So let's get started. So first thing, we are importing the necessary libraries, again our numpy, pandas, matplotlib and seaborn. Then we import the data. So we are defining the column name here, and in which we are defining all the columns that we have. So you can see that intercolumnar distance, upper margin, lower margin, so on so forth, and the class column, right? Now we are getting the train from the train data set and test from the test data set, right? So if we get the head of train data set, so you can see that this is what our train data set looks like, and these are the alphabet that you can see, a, right, and so on so forth. The number of alphabets will be there. Now let's brief this. So what we are doing is we are getting the information of train. So we are using train.info function, which will return all the information of our train data set. So here you can see that there is no null values, right? So we are free from that. Secondly, all of the feature are floating points. Yes, you can see that. And we have 10,429 instances and 11 columns, as you can see here clearly. Okay, now pd.data frame, right? So we are getting the data frame, and what we are doing is we are telling that okay, in train just take the value of the train class, right, counts of these. Okay, and which will be percentile in train. So we are rounding off. So you can see here, these are the total number of a, right, in our train data set. Secondly, we are getting the percentage. So percentage from where? So this is x divided by length of train of class data set, right? Train data set and class attribute for x in train class dot value counts. Okay, so that means it will give the percentage from all the values of this a, then this f, and so on so forth. Similarly for test, it is same that this is the value count of test data set, right, at these characters, and the percentage in test. So again, the percentage in test, that means the percentage of a in the whole data set, right, in the test set. Now the above number tell us the class distribution of both the data sets. Yes, now let's pair plot it. So we are defining sns.pair plot, in which we are passing train diagonal kind, this kde u is on basis of class, right, and plt.show. So here you can see that we are getting all the plots for all our characters. So these are the classes that hope you can see it. If I zoom in, no, still not. So let me reset it. Okay, so here you will be able to see these classes here. All the classes are here, and pair plot are accordingly plotted here. Now there doesn't seem to be any apparent relationship amongst variable, right, linear otherwise. Okay, and most of the data point overlap for any two given features. Yes, and let's carry on with the training our model to classify the data. So for that first thing before that we will pick out X, that is predictor S, and Y, that is response. So we are taking X train and Y train. X train in which it will train the train dot drop column, so the rest column will be our X train, and Y train will be the class column in the train. Similarly for Y test, X test and Y test. So for X test, it will be from test dot drop the class column, so rest of the columns will be in our X test, and Y test will be test of class, so only the class column of the test data set. Now train and evaluate model. So first thing we are applying here is the logistic regression, again importing it from sklearn linear model, and it is logistic regression. Then logreg, again logistic regression solver, we are defining liblinear, right? Multi-class we are defining auto here, and logreg, if we do fit function, so from here we will pass X train and Y train. So this way you will get the logistic regressions functions, right? Now if we get the score, so logreg dot score, now we will pass X test and Y test to validate or test the data set. Now the F score will be our this LR score, that is this one. So it is nearly 53%, so we can say that the accuracy is 53%, possibly because of this imbalance, right? And since it is multi-class problem, simple accuracy does not give us the whole picture. So let's check what percentage of each class has the model got right. Now prediction, that will be our logreg dot predict, which is X test, and then we are defining a function that is rightly identified to check whether it is identified rightly or not. We are defining a variable A which will contain empty data frame here, right? And then for I in np dot sort actual unique, right? And we are using the try catch block, in which the need is because we get a key error if we use value counts, this one I, when the given class I does not exist in the value counts array. So a log, that will be total instance, it will be length of actual equals to I, value count of a given class I, and a dot log I identified right, pd dot series prediction, so actual will equals to I, value counts I, number of instances where a given class I was identified correctly. Similarly a dot log I equals to percentage round 100 into pd series prediction, actual equals to I, right? And it will give the value count, and then we will get the value count of that particular I, which will be divided. So here it will give nothing but the percentage of the prediction that were correct for a given class. Okay, similarly now expect, that means if the key error discussed above, this one, right, assign the percentage 0, so then it will return what, the 0.0. okay, and finally A will return here. Now the new variable, that is prediction versus actual. So again we are calling the rightly identified function here, passing Y test and the prediction. So if we get the value correctly, so here you can see that it has returned the total instance. So A total instance, right, identified right, is 4158, right, 90% of accuracy. B, the total instance is this, identified 2, so the 40% of accuracy. C, you can see that total instances were 103, but identified were none, so none of them could be identified correctly. So what the main aim of this model is, basically this has got 97% of A is right here, right? Likely because that was the dominant class in the data set. 0% you can see of C, D and G, W were identified correctly. Okay, and even though there were only 5 records of B for the model of train, the model correctly identified 2 of the B's in the test set. Okay, Now let's get the confusion matrix, right? So we are defining the function for confusion matrix, again passing the actual values and prediction values. So this is how the confusion matrix actually works. Okay, now from sklearn.matrix import confusion matrix, right? Matrix, we are defining pd dot data frame. Now we are calling confusion matrix inside it, actual value and prediction value. Then column will be np dot unique actual columns, right? Actual values, and index will be for actual columns as actual values as well. So the confusion matrix, basically it will return the confusion matrix, wrapping this matrix in a data frame with appropriate column names and index. So you can see that how nicely it has wrapped with the data frame. And now matrix dot log, so it will be our total count actual class, that will be matrix dot sum x is equals to 1, so sum across the column. Okay, and next thing matrix dot log, it will be total count predicted, that will be matrix dot sum which will be x is equals to 0 row sum. So this is how we will get the returned matrix here. So here you can see that it shows the confusion matrix here, right? And the diagonal, you can see that the diagonal values tell us the correct predictions. Okay, so total count predicted is here and total count actual class is here. So from the table we can see the model classified 8391 instances from the total of 10437 test records as A, while only 4158 of them were correct. Okay, so this is what you can see, that A has 4158 correct, and B looks like the most unique letter of the of all, because the model did not classify B to be anything else except B and A, right? So you can see that for B here as well. Next thing, we are applying knn here. So from sklearn.neighbors importing k neighbors classifier, right? So this is k scores we have defined empty, right? And now for I in range 1 to 20 knn, we have defined a classifier that is calling from here n neighbors equals to I. So whatever I we pass here from the range, right? And knn dot fit will be our based on x train and y train, and we will get the s as knn dot score, which will give x test and y test score, and we will append that k scores in this actual variable. Now if we plot the once the loop is done, right, every value is done for that from 0 to 19, sorry, from 1 to 19, then we will plot it as a range of 1 to 20 k score, right, based on this data. And these are the plotting symbols that we want, and plot x sticks will be range of 1 to 20, that means 1 to 19, and plt shows, so it will show the datagram, it will show the plot here. Now if we get the knn, so first thing we are defining n neighbors as 3, so we are calling the k neighbors classifier, right, passing the n neighbors as 3. Now trying to knn dot fit, in which we are passing x train and y train, and here you can see that it is returning the trained or fit model. And then we are defining knn score, so it will return the knn dot score from x test and y test after calculating that. And if we get that score, that will be written in percentage. So you can see that the score that has become this time is 75%. So let's see the prediction. So if we do knn dot predict x test, right, our prediction on that, and we again do the prediction versus actual knn, so rightly identified, again calling the same function, passing the y test and prediction this time here, and let's predict this. So after getting the values, so you can see that again we got the model. So same thing, again we define the confusion matrix for this model as well. So these are the observation here. Now this time all the B's were rightly identified to B's, and we have also earlier seen that B is probably quite unique from the other letters, right? So you can see that B with A is nothing, B with B is 5. Okay, so which is correctly identified this time. But earlier you could see that B with A was 3 but B with B was 2. Hope you got the difference here. So now performance of the KNN is much better than that of logistic regression. So next thing, let's try with the naive Bayes as well. So the same thing we have done with the last two model, that is logistic regression and KNN. This time we are doing with the naive Bayes. So again importing Gaussian naive Bayes from naive Bayes. So NB will be our Gaussian naive Bayes, right? The variable that is containing the Gaussian naive Bayes. Now we are fitting the Gaussian naive Bayes. So here we are passing X train and Y train, fit the model, getting the score. So the score you can see that seems very less, that is 29%. Now let's predict it again, doing the same thing, calling the rightly identified. So passing Y test and prediction of the naive Bayes predict X test. So this time again you can see the table that we got and the confusion matrix. So what the observation we have, B seems to be easiest later to identify. So here you can see that B is again the same got with B, but A is the toughest later for naive Bayes to identify. So you can see that it is very biased this time. A with A with C, everything A is like splitted. Okay, so let's put the model result together to be to a comparison. So what we'll do is we are taking a dictionary, defining result. So first thing, logistic regression, we are getting predict versus actual logistic regression. Then KNN, predict versus actual KNN. So, but this time we are dropping the total instances because we don't need it because we already got it from the first logistic regression. Same thing we are doing with naive Bayes. Again we are dropping the total instance, just keeping the total instance of logistic regression. And now we are concatenating all these data sets. So concatenating results, X is equals to 1, all the columns wise, right? So here you can see that the difference, these are the total instance rightly identified with logistic regression is 4158, 97% of accuracy of A I'm talking about. Naive Bayes identified right, 272, 6.3% of accuracy. KNN is 86% of the accuracy. But if we check with all values, so B you can see that total instances was 5, right? Rightly identified with logistic regression was again 40%, and naive Bayes with 100% and KNN with 100%. But if we sort it again, so here you can see that PD dot data frame accuracy. So this time accuracy of logistic regression, KNN score and naive Bayes, giving the index of logistic regression, KNN, naive Bayes. So here you can see the total accuracy, or we can say the score that we got earlier. So logistic regression 53% of accuracy, KNN giving 75% of accuracy, and naive Bayes is giving 29% of accuracy. So if we conclude this, so KNN has arguably performed the best of all model. Okay, now naive Bayes, even though has the least accuracy, but it has been able to identify G and H better than all the models, right? So here you check particularly for G and H, right, 447 527, and check for naive Bayes. So you can see 52 and 53%, sorry, naive Bayes is 70 and 81% of the accuracy. So yeah friend, this was all about this video. Hope you got the slight idea that how can we get the analysis of the all our logistic regression, naive Bayes and KNN in the alphabet identifications. So it was all about this video. Thanks for being with us. We will come up with another interesting video. Stay tuned. Like, subscribe if you really like the content and want us to upload similar content more, right? So please do let us know, and if not, please give your suggestion as well, so that will help us to improve our content and everything that we provide. Thanks.